Let's study dimensions of a physical quantity. What is this term? Dimension is in fact a power or exponent. This is power or exponent of what? Exponent of base units. Okay, exponent of base units, power or exponent of base units. And why the power is raised to the base units? To get derived unit of that quantity. To get a derived unit of that quantity. Let's understand it. This is dimension is what? It is a power or exponent of what? Exponent of base units are what? It is mass, length, temperature, Kelvin, etc. Okay. Now, if suppose that we take length, we have to get what? Volume is what? Volume is L into L. That is L3. So the power of L is raised by 3 to get a derived unit of that quantity. Okay. The derived quantities are written by raising the power of the base quantities, that is fundamental units. Now here we see how we represent a dimension, a representation. To represent we use this square bracket. This is what? This is a square bracket. This is a square bracket. Suppose we have to represent the dimension of length, that is dimension of length is, we will represent in this way. If somewhere is written under bracket, under square bracket, it is m. What does it mean? It means it is dimension of mass. Okay. And if it is written under a square bracket, it is called dimension of time. Okay. And for temperature, it is what? K means under bracket K. This is the representation of dimension, that is square bracket. Okay. Now let's see how to find the dimension. Okay. Here in the previous example we saw volume is what? In fact we see volume is side cube. Volume of a cube is what? Side cube. Side is what? Side is a length. So it is L3. And here in volume what we see? Does it have mass? Volume has no mass. Does it has time as a governing factor? Volume has no time as a governing factor. It has length only as a governing factor. So what we will write it as a dimension of volume will be written as what? This will be written as mass. There is no mass, so it is 0. Power is 0. It is having length or not? Yes, it is 3. Time, does it have any power? Time is not a governing factor of volume, so it is 0 here. Now this is the way to represent the dimension of a volume. Okay, for volume it is this. And now let's see force. One other example, how to find the dimension of force. This is one example. Another example is force is what? Force equals to mass into acceleration. Let's convert this acceleration. This is a derived unit, so we will convert it into basic unit. Mass is already basic unit, so no need to convert mass. Now mass is left as it is, and acceleration is change of velocity. Sorry, it is delta v by t. That is change of velocity by time. So it is, in fact you can write in this way also, mv by t. And velocity is also a derived unit, and so velocity will be changed one other time. Mass into what? Velocity is distance means s, distance by time. So one time and one time more, so it is t square here. Now let's see, mass is a basic unit. Mass is basic physical quantity. So okay, mass is not a unit, kg is a unit. And distance is a physical quantity, that is length. This is also basic. This is also in basic form, fundamental form. Okay, so now the three governing factors of force is in the fundamental form. So now we will write the dimensions. The dimension will be, it can also be resolved as mass in m into s into t to the power minus 2. It can be written as, so the dimensions will be for mass s, that is L, because distance is termed as L, and t to the power minus 2. This is the answer. Okay, now we found the dimension of force in this way. Now there is a very important question. Find out the dimensions of universal gravitational constant used in Newton's law of gravitation. We have to find the dimension of what? Universal gravitational constant, that is capital G, used in Newton's law of gravitation. Now how we will solve? Let's see. The solution is, at first, according to Newton's law of gravitation, what is the, in which formula gravitational universal gravitational constant is used? We will remember. The formula is F equals to capital G m1 m2 by what? R square. Okay, this is the formula, and this is what? Gravitational constant. G is universal gravitational constant. Okay, so we have to find the dimensions of this G, this one here. So separate this G here, left side. What we will get? F R square by 1 m2, isn't it? We will get here in this way. Now start resolving. For dimensions, what we do? We start resolving. This is force. Right now we had calculated the dimension ml minus ml t to the power minus 2. Okay, and this mass, this is already a basic unit, basic physical quantity. This is already basic physical quantity. Distance, this is already basic physical quantity, so no need to change it. Now this is a derived physical quantity, force. So this will be converted, or if you remember the dimensional formula, directly put here. There are two ways. We know force is ml t minus 2. The dimensional formula is, so we will put here, and for r square it is l square. We will put here, and for m1 m2 it is this. We put it here. Okay. We directly put force as this because in the previous question we have already calculated force. Now here, solving this, we will get how many powers of m? Power 1 here, power 2 in the denominator, so the resultant will be minus 1. Okay, this is power L, nothing is written, means 1 is written. 1, and here 2, that is 3, and T, this is only minus 2. This is the dimension of universal gravitational constant. Thank you. Now let's see one other question. Suppose it is asked that find the dimension of work. Now how will we solve? Let's see. We know that work equals to what? Work equals to force into displacement. That is, this formula we already know, and this displacement, this is already a fundamental physical quantity, so no need to resolve it further. Directly it will be L. In the place of this we will write the dimension L, and for force we know that it is mlt minus 2. Okay, so the dimension of work will be what? M is only one single piece, so it is written as it is. L is work, 1L here, so it is L to the power 2, T to the power minus 2. This is the result. The dimension of work is, this is not only the dimension of work, this is also the dimension of energy, because energy equals to work. So the dimensions will be same. Thank you.